I think we need some practice rationalizing denominators, so we're just going to show a quick example like this. I'm not allowed to have square roots in the bottom of my fraction, so what I'm going to do is multiply by 1. But I'm going to be very specific by what 1 I'm going to factor by. I need to get rid of the square root of 7, so the easiest way to do that is to multiply it by a square root of 7. But I can't just multiply the bottom by the square root of 7. I'm going to multiply by the top, or the top by square root of 7 too. When I divide by square root of 7 over square root of 7, I'm really multiplying by 1, just like 2 divided by 2 is equal to 1, or 173 divided by 173 is equal to 1. So when I multiply by 1, I'm not changing my expression at all. What this becomes is, on top of my fraction, I'm just going to multiply straight across. I get 14 root 7. On the bottom of my fraction, I get, underneath the radicals, I can multiply those things together, so I'm going to get the square root of 7 times 7, which is 14 over the square root of 7 becomes the square root of 49, and the square root of 49 is 7. So 14 times the square root of 7 over 7. I'm not quite done yet because 14 divided by 7 is 2. So I can simplify that. So this is just going to be 2 root 7. And that is how we rationalize the denominator, which will come in handy when we're dealing with our special right triangles.